Hello guys, I am Science Man and welcome to Science Man Laboratory. I am a new YouTuber and I am going to help you with various types of physics and chemistry, biology topics. Today we are going to dive into the topic of magnets and magnetism. We will learn electromagnets in the next video. So let's start. What is a magnet? A magnet is a material or object that produces a magnetic field. That this magnetic field is invisible but is responsible for the most notable property of a magnet: a force that pulls on other ferromagnetic materials such as iron, steel, nickel, cobalt, etc., and attracts or repels other magnets. So a magnet is a material of the or object that produces a magnetic field. This object has some kind of power that produces some kind of radiation which attracts metals like such as iron, steel, nickel, cobalt, etc. And and what is the meaning of ferromagnetic? Ferromagnetic are easy. It's easy. The ferromagnetic materials are iron, steel, nickel, cobalt. Ferromagnetic materials attract magnets, or the opposite. So, and in here we've got some points. An object that attracts certain metals, mainly iron. It attracts mainly of the iron object. Magnetism decreases with the distance from an object. The magnetism decreases with the distance from object. The closer you get, the stronger the magnetic field will be, and the further you get, the weaker the magnetic field will be. Permanent magnets keep the magnetism for a long time. Temporary magnets lose the magnetism after a short time, as you know. Next we'll go to um, history of a magnet. So about 4,000 years ago, the ancient Greeks discovered rocks which possessed the property to attract iron objects. They named them magnetite, and then so the first name of magnet was magnetite. Then later on, due to the discovery of the directive property of magnetite, when suspended freely, they always rest in the north-south direction. As if you if you put some what do I say, one beam rested on top of another beam, and then with a string you entangle an magnet a magnet. you will always see you will always see the north pole will always point to the north direction, and the south pole will always be pointed to the southern direction. So after later on, when suspended freely, it always is in the north south direction. Then then later on, due to the discovery of the directive property of magnetite, we don't know that. Its name was changed to lodestone. So what do we know now? What is a magnet? What is a magnet? There are and I want to tell you that more information. There are two types of magnets: natural magnets and artificial magnets. Naturally occurring materials like lodestone, which possess the inherent property to attract iron, are known as natural magnets. But they are weak magnets. Natural magnets are weak magnets. However, the magnets made by human, that is artificial magnets, are stronger magnets. The magnetic field are very strong in artificial magnet, but the magnetic field in natural magnets are low. And you know that these magnets are made of they are made of iron, cobalt, nickel, etc. They are also made of iron, cobalt, nickel, etc. As these materials can be magnetized easily, such magnets are available in different shapes and sizes according to the purpose they serve. Magnets have a number of applications. They are used in refrigerators, as you know, fridge magnets for fancy look for fancy look of the refrigerators, computers, televisions, CDs, generators, the doorbells, etc. Um, the magnets inside a computer help us to store data. Okay, televisions also like that. They help us to display these things and that thing. CDs also like that. Now, magnetic and non-magnetic materials. First, we want to know what are the types of magnets. There are three types of magnets. One, there were there are two types of magnets which are artificial energy magnets, and there are three examples of magnets. Types of magnets, examples of magnets. Okay, there are three kinds of magnets: horseshoe magnet, bar magnet, disc magnet. A horseshoe magnet is a magnet in the shape of a horseshoe or a U shape and has become the most widely recognized symbol for the magnets. It was invented by um, William Sturgeon in 1825. And you will always ask, who is William Sturgeon? William Sturgeon was an English physicist and inventor who made the first electromagnets. We will not dive into the topic of electromagnets now. We will do it in the next video. So, who made the first electromagnets and invented the first practical English electric motor. So, it was invented by William Sturgeon in 1825. This type of magnet can be either a permanent magnet or an electromagnet. And horseshoe magnet can act as electromagnet also or a permanent magnet, but to the properties of the type of the horseshoe magnet. Then we'll go to the bar magnet. A bar magnet in the shape of a bar whose magnetic force is strongest at its poles. Poles means the ends, the ends of the bar magnet. So one hand attracting iron steel objects and other end pushing them away. So the pushing is the repulsion, and iron steel that stick that that suddenly stick with the magnet is called attraction. So now next we'll go to the disc magnet. The magnet is in the shape of a disc with a flat surface and poles area. Due to its area, it's considered as an effective and strong magnet. As you know, the the right side of a disc magnet is the North Pole, and the left side of a disc magnet is the South Pole. So we know what are the kinds of magnets. Sorry for the typo here. Next, the properties of magnet. Let's go to the properties of magnet. So properties of magnet. Magnets attract Magnets attract objects made of iron, nickel, cobalt that we know. Magnets have two poles, the North Pole N and the South Pole S. Poles that always exist in pairs. They cannot be separated. If you break a magnet, the two halves will also the two halves ends will also create a North Pole and South Pole. And then opposite next property. Opposite poles of two magnets attract each other. The opposite poles the South Pole will attract the North Pole of another magnet. See the magnetic lines here. They are attracting. They're sticky. They're going to stick. Like poles of two magnets repel each other. See these lines. These lines are going towards. So it will repel. It will not stick. So if a magnet is suspended freely by its way, it aligns itself in the opposite direction, as we know always. Next, magnetic field of different types of magnets. This is the interesting part. So let's know what is a magnetic field. The definition. So um, a magnetic field is a vector slash magnetic field. Vector field and magnetic field is the same. That describes the magnetic influence on moving electric charges, electric currents, and magnetic moving materials. A moving charge in a magnetic field experiences a force perpendicular to its own velocity and the magnetic field. So we know that magnetic, what is the definition of the magnetic field. So now magnetic field of different types of magnets. Magnetic field of a bar, see, it goes like here, like here, like here, like here, like here, like here. Okay. Magnetic field of a horseshoe magnet. Magnetic field comes from here, suspends from here, 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 here. Magnetic field of this magnet goes like this, roundabout, roundabout. It looks like an eye. It's the hypnotizing. The hypnotized, you have seen in some cartoons. Sorry for that. Cartoons that the hypnotizing, it's like that only. Then magnetic compass. What is a magnetic compass? A compass is a device that shows the cardinal directions used for navigation and geographic orientation. It commonly consists of a magnetized needle or other elements such as a compass card or compass rose, which can pivot to align itself with magnetic north. See this? Here, this needle will always align itself with the north and the south direction. If you want to go to the north direction, you will follow the needle, the pointing with the north. So, now the properties of magnetic lines of force. The properties of magnetic lines of force are each line is a closed and continuous curve. It always curved. It is always curved. Go from the north pole. It goes from it starts and the south pole. It comes in and both sides they round about. The originate from the North Pole and terminate at the South Pole. As I said, they will never intersect at each other. Obviously, they are crowded near the poles where the magnetic field is strong. Say where I keep a disc magnet in a place, and then let's say what do we put? Some iron material like the sharpener's blade. It's iron. Yeah, it's iron. So there will be the magnetic field will be strong. The effect they affect the magnetic compass needle. As you know, the the needle of the compass will always be the north the north side of the needle will always be north pole, and the south side of the needle will be at the south pole. So last but not least, the our Earth's magnetic field. This is our Earth's magnetic field. This is the Earth's magnetic. This is the axis, the geographic north pole of the Earth. This the geographic south pole. So Earth's magnetic field, also known as the geomagnetic field. Geo means Earth. We study about Earth geography. Okay, is a magnetic field that extends from the Earth's interior out into space, where it interacts with the solar wind, a stream of charged particles emanating from the sun. So you will ask, what is emanating? Emanating, let's see, emanating. Let me think. Yes, emanating means issue or spread out from a source. A source. You figured out that I told from Google. Yeah, I didn't know, but I searched from Google also. So we have covered our magnetism chapter. In the next video, you will see about the electromagnetic field and the study about electromagnets. So thanks for watching and goodbye.